Hello, welcome back to the class of natural gas engineering. We are discussing the amine process and the operating difficulties that we are facing. In the last lecture, we talked about the foaming, and now we are going to talk about the meat gas specifications. Well, there could be a number of reasons. Then the H2S. First of all, you need to understand what does it mean meat gas specification. It means that the amount of H2S and CO2 you want to recover, it has to be meet the requirement of the customer. So you want to remove the H2S and CO2 that much so that the customer accepts it and simply in simple words. So sometimes, but this is not the case. Sometimes the plant is not efficient and H2S is not completely removed or CO2 is not completely removed. So what are the causes of to 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 not have a removal of H2S and CO2? What are the causes that the plant fails to meet the criteria of the customer or fails to remove the H2S completely? Well, first reason could be solvent circulation. Maybe the amine you are processing, the quantity is not uh, too much or is not according to the needed. So maybe one of the reason could be the circulation is low. The amount of amine circulating in the system is low and could be one of the main reason. And another reason could be inadequately stripped solvent. The in the another reason that the H2S is not removed properly or completely is because the solvent amines that we are injecting is not clean enough. It is contaminated. That could be another reason for inefficient H2S removal out of it. And sometimes the solvent feed ratio is too cold. Sometimes the temperature is not good enough. Sometimes there's the CO2 inside the raw gas, so the ratio is not good and the temperature is not suitable to do this reaction inside. And sometimes it's too hot, H2S and CO2. So we have to look at the temperature of the stripper column or absorber column, that what's the temperature inside, because temperature plays important role in removal of this uh, H2S and CO2. Sometimes the amine is not strong enough, the solution is not good enough, that's why it could be. So sometimes there's a foaming issue. So all these issues, sometimes the mechanical issue, sometimes the baffling plates are not working, and sometimes there's a leakage. So these are the reasons that amines, the efficiency of H2S and CO2 removal is compromised. Well, in the case of foaming, the gas remains trapped inside the bubble and the unable to contact the rest of the solvent, resulting in poor mass transfer. Sometimes there is a mechanical foaming issue, and because of foaming, the bubbles are trapped, and they don't meet together inside, so no chemical reaction occurs, so no H2S and CO2 is removed. Sometimes the trails are broken, mechanically issue. So these are some of the issues of the uh, operating issues of not meeting the solvent losses. Well, a major cost inside this amine process is the solvent, and sometimes their losses are occurring. Either the losses are because of this foaming issue, okay, foaming or excessive gas velocity. This is one of the reason the amines are lost. Another by the leakage due to the spills or corrosion. Okay, these are the two main regions where the amine losses can occur. Okay. On a much smaller scale, uh, vaporization can happen also, in a condenser, flash tanks, and can knockout drums or wherever the vaporization process can happen, and this can also reduce the solvent. And sometimes the thermal degradation because of very high temperatures can happen also. So we have to monitor the solvent process and throughout in this one, in this case. And then in the end we have the corrosion, and corrosion could be because of the amine concentration, could be because of the H2S, could be because of the temperatures or salts, elevated temperatures, or velocities. So this could be, or sometimes the water, if it has lots of water vapor, all of these reasons could lead to the corrosion factors. And corrosion can cause a leakage, and if the leakage happens, the amine concentration will be low, then the H2S requirement will removal requirement will not meet, so all the process will not be fine. So if any of this problem happens, uh, then it's not good enough, because this one problem can lead to all the problems inside this amine process. So for gases containing higher ratio of CO2 to H2A, Rich acid gas loading should be maintained at the lower end of the recommended loading rate. So you have to monitor how much the amount you are sending into the stripper column if you have very high amount of CO2 or H2S, because otherwise if you don't maintain it, then the efficiency will be compromised of removal the H2S and CO2. Well, then one of the reasons you can solve this corrosion problem when you can use this type 304 stainless steel, because stainless steel will not let it for the corrosion, and it will reduce the corrosion issue inside the plant. And where this stainless steel is used in the lean and rich heat exchanger tube bundles, reboiler tube bundle, stripping column, upper section or overhead gas line, reflux condenser, rich solvent let down the wall, and these all things can with their stainless steel is used. So now I will show you some of the pictures of the plant where we have this. This is the simplified amine gas treatment plant. Look at this one. This is the foam, and you can see here this is the foam generated inside. This is because of the degradation. Look at the corrosion. This is crevice kind of corrosion inside it. This is the pitting corrosion, causes the pit and causes the leakages in the pipes. Look at inside the pipe. The fouling effect, how the pipes are choked with waxes, and this is so that's all for this amine process. And I hope you like this lecture, and now we will talk about the dehydration process in the next lecture.